So how do you find the asymptotes of a rational function without making a table for it? Well, it boils down to three cases. Case one is when the degree of numerator is equal to the degree of denominator. So that might be, like we did in the previous video, y equals x plus 1 over x minus 1. The numerator has degree 1, and the denominator has degree 1, because these are the exponents on the leading coefficient. Leading coefficient is here and here. So how you find the horizontal asymptote in this case is you take the ratio of the leading coefficients. So in this case, it's just 1 over 1. So 1 over 1 is 1. So that's the horizontal asymptote. If we had y equals like 3x plus like 8 over negative 5x plus 2, it'd be the same idea. You just take the leading coefficient, 3, negative 5, put them in a ratio of 3 over negative 5. So negative 3/5 would be the horizontal asymptote. There is also another case. Let's erase this. Case 2, or I should probably write the finding. Horizontal asymptote equals ratio of leading coefficients. Alright, case 2 is that the degree of numerator is less than degree of denominator. And that might be something like y equals 1 over x plus 1. Well, the degree of the numerator is 0, and then degree of the denominator is degree 1. And in that case, the horizontal asymptote is 0. You can kind of see this intuitively, because if you try to plug in things for x here, maybe you plug in like 100 for x, you get 1 over 101. If you plug in like 1,000,000 for x, you get 1 over 1,000,000 and 1, and you just get closer and closer to 0. So another example of this, just to gain more intuition, is something like x to the 5th over x to the, or plus 1 over x to the 10th minus 3, something like that. Well, this is degree 5, and this is degree 10. Even though the numerator gets bigger as we plug in values of x, like initially when we plug in x in 1, x is 1, the numerator is 2. When we plug in x is like 10, the numerator is 100,001. Well, the denominator is getting bigger even quicker. So we've got 2 over, well, when x is 1, we've got negative 2, but then when x is like 10, we've got like 10 to the 10th minus 3, and that number is like, that's bigger than a billion. Yeah, so takeaway, horizontal asymptote is 0 when the degree of numerator is less than the degree of denominator. There's one final case and you can probably guess what it is. Case 3, degree of numerator is bigger than degree of denominator. And in this case, the horizontal asymptote, well, there is no horizontal asymptote because it blows up to infinity or negative infinity. Reason for that, well, let's just work an example. So y equals maybe x squared over x plus 1. When we plug in a really big number for x, we just make the table, xy. When x is 1, we get 1 over 2. When x is 100, we get 10,000 over 101. When x is like 1,000, we get a million over 1,001. This thing is roughly 100. This thing is roughly 1,000. So we draw the graph. It's just going up to infinity. Yeah, so that's. So these are the three cases. Every time you have a rational function, you just need to see what case it falls into, and then that'll tell you how to find the horizontal asymptotes for it without having to make a table. But if you want to gain more intuition for it, maybe you can just make the table every time, and eventually you'll kind of just internalize what's going on and not really have to memorize these rules because they'll just seem obvious after you make the table enough times.